All right, so the ammeter project that's in the lab manual tells you a lot of stuff about ammeters, and there are two basic kinds of ammeters. One's a clamp-on and works on the Hall effect, and it doesn't have to be broke. You don't have to break into the circuit. Then the inline ammeter is built into your Fluke 117, and you have to break into the circuit in other words, put the meter in series in your circuit, because current's constant in a series circuit, right? So if you break into a circuit and put the meter in the series in the circuit, you'll be able to read the current. Okay? Now, what's the problem with reading very small amounts of current? A clamp-on ammeter does not read small amounts of current very terribly accurately. So, you need to know something about reading current with a clamp-on ammeter. A clamp-on ammeter has a part that opens up the jaws and you clamp it around the wire, right? What if you take the wire and wrap it around the clamp 5 times? What current will you read? It'll be the same. If you were reading 1/10 of an amp before, how much current will you be reading now? 5/10 of an amp, okay. 50 milliamps, right? Oh, there's that engineering notation thing again. No, 5/10, yeah. 500 milliamps. I'm incorrect, thank you. So, 500 milliamps, half an amp, right? Okay, that's easy to read for a clamp-on ammeter. But does that give you an accurate reading? No, it gives you 5 times the accurate reading. So what we're going to do, in spite of what the lab manual says, what we're going to do is we're going to take 2 meters and we're going to hook them up at the same time. We're going to hook up an inline meter. You're going to do the stuff in the project manual, but plus the job check will be based on doing the following. You're going to connect an inline meter, your Fluke 117, and read the current of the circuit that you're instructed to read. And then you're going to take a jumper and extend the wire that you're reading and wrap it around a clamp-on 5 times. All right? So it becomes a very quick and easy project after you go through the lab manual and do the things it tells you to do. Now, if you're going to use your inline ammeter, one of the things you never want to do is put your meter in the circuit, turn it on to read amps, and then turn the circuit on. Any circuit in the world has current inrush, doesn't it? If you turn on a light bulb, it has current inrush. If you start a motor, it has current inrush. Higher current than it would normally have for the first split second. You might damage your meter. So we don't do that. What we do is we short around your meter so that it sees no current at first when the circuit is first energized. Then we remove the jumper. And any time you read current with your ammeter, your inline ammeter, I want you to short around it when you first start the circuit and then take the jumper off to protect your fuse. Now, it is good to have a fuse because you're not blowing up and throwing away a cheap meter, right? Instead, you might blow up a fuse, but the fuse in this thing, in the Fluke 117, costs more than some cheap meters. The fuse is about $15, and they're hard to come by. You have to go to Fry's Electronics or someplace that carries this particular very accurate fuse, very instantaneous fuse. Okay? So you want to avoid blowing up your fuse or your meter, and you short around the load, turn the circuit on, and then take your short circuit off. Make sure you're not reading voltage when you do that, otherwise you're going to have flaming wires. A really cheap barbecue. We don't want to do that. Okay, don't let the smoke out. All right, that's all I want to say on those 2 projects. Everybody okay? Any questions on these? No questions? So you know everything perfectly clear about those two projects. Great.